All right, let's do intermediate value theorem. This is 2.4, part D, intermediate value theorem. It's very often abbreviated IVT. So what we need, f of x must be continuous for this to work. Must be continuous over a closed and bounded interval AB. We mentioned what closed intervals were in the last one. Bounded means there's a max and a min, maximum and a minimum. I.e., no asymptotes. But I guess that would break the continuity already. But that's what bounded means. There's a maximum value and a minimum value. Then we also have, if that's the case, then there is, hold on, a little bit more. And then we have a value with a y value let's call it z, just so it stands out, between f of a and f of b. So let me draw a picture of kind of like what's going on here. So we could have some stuff going like this. I'm going to say, I don't know, A is here and B is over here. That makes this point A f of A. And this point right here, up here, would be B f of B as a point. So over here, if I put it on the axis, I got f of B over here. And if I put f of a, I've got f of a over here. Then there's some value z in between them. Let's say z is here. Shit, I could even do it down. I could do a different one down here. The point is, like, this one's a little bit easier to show. This one has a point. It shows us that there has to be a point that an x value works here. But this first one is not really in between AB, so I'm going to get rid of that. So maybe right here, this would be, then there is a C in AB, like A is less than C, less than B, where f of C equals Z. So if I call this like C1, then this value has f of C1 equals Z1. And if this is C2, Z2 is f of C2. Now, this is often used to do almost like what I did right here. I'll do it slightly different. I've got A lower on the left and higher on the right, but I could I could do A here, B here, and have it going like this, where that's f of A and f of B is down here. One doesn't have to be lower than the other. This is often used to find zeros. And zeros are where f of x equals 0, which in this case is right here. So they do this by showing f of A is greater than 0 and f of B is less than 0, like I had in that picture, or f of A is less than 0 and f of B, wait, these should be opposite signs. There we go. F of B is greater than 0. There is a C, let's call that C, in a B where fx equals 0. This is how intermediate value theorem is used a lot. So let's do an example where you see that in play. Let's show that f of x equals x cubed minus x squared minus 3x plus 1 has a 0 in 0, 1. Well, first off, this is a polynomial, so it is continuous. That's required. And then the way we do is this is A, this is B. Let's find out what f and A and f of A is and f of B. F of A is f of 0, which is 0. That should be a cube up there. 0 cubed minus 0 squared minus 3 times 0 plus 1 is just 1. And f of B would be f of 1 here. 1 cubed minus 1 squared minus 3 times 1 plus 1. This is 1 minus 3 plus 1 is negative 2. So f of A is greater than 0. F of B is less than 0. That means somewhere inside, somewhere in 0b or 0, 1, there is a C, x equals C, where f of x equals 0. It has to cross somewhere. This idea is like part of it's positive, one side's positive, one side's negative. And we draw it without picking up the pen. It must cross the x-axis, where f of x equals 0. Okay. Two things I want to note. Note, if f of A and f of B are greater than 0, both greater than 0, or both less, IVT doesn't help us. And I'll show you why. Like, let's say here's A and here's B. I could have a graph like this that does this, and we have, let's say it keeps going. So we have no zeros on the blue line. But it could also do something like this, and we have a bunch of zeros. So IVT doesn't help us if the signs are different, and it doesn't exclude zeros. And the other thing to note is make sure it's continuous. What in the world there? There we go. So like if f of x equals 1 over x, and we're looking at -1 to 1, f of -1 equals 1 over -1, which equals -1. F of 1 equals 1 over 1, which equals 1. One's less than 0, one's greater than 0, but f of x isn't continuous. That looks terrible. Let's fix that. So IVT doesn't work. This is looking at this. There is no 0. Even though IVT looks like it says there's a 0, it's not continuous, so it doesn't work. All right, that's it for 2.4. I'm going to close out of this, and as soon as it's done doing it, I'll upload them. Peace.